Hi, I'm Chris. I work at Nature Robots as a robot software engineer, and today I will present the Horti navigation operating system. The operating system that we provide can be used on different autonomous machines, which do tasks from seeding all the way to harvesting. These days, especially a big topic is weeding, from mechanical weeding and also for laser weeding. For the mission planning, we are computing the perfect path for the autonomous machine to take. Considering certain facts, like for example the length of the beds, the weather, the weed pressure, for example. With the weeds especially, laser weeding is very good for small weeds, while mechanical weeding is better for larger weeds. So that is all taken into account with the mission planning. With the mission scheduling, you then take the plan and you decide when to execute it, basically. So the user can see how long it takes, on which days, what tasks get done. You then bring the robot to the field, you start the mission, and then you can use our robot nav UI to see how long the mission will take, which tasks the robot is doing, and see, for example, its battery level. Our operating system is very modular, so we support different width of the beds. Certain autonomous machines are capable of driving over multiple beds at the same time because they are wide enough. The beds are defined by only their start and end point, and so in between we are using our reactive row following. This is a lot more robust because the bed is not defined by a lot of specific points, and that would probably cause us to also drive on the beds sometimes. And with the reactive row following, we are following the actual path of the bed. So if it's curved, we follow the curve. If it's straight, we follow the straight path. Our navigation is based on a graph structure, and all our operating systems are using the same basic graph structure. The edges in the graph use different controllers. So for example, while driving to the beds, we can use free space navigation to automatically avoid obstacles, for example. While driving on the beds, we can then use a controller that uses the wide configuration of the autonomous machine. And then when switching beds, we use the small configuration to use less space. Here in the horticulture environment, the graph can be either imported from another machine, for example, that has already driven over it. But the main part is that you actually manually create it in our robot nav UI. You can edit it there. You can use the measuring poles to then measure the exact start and end points of the beds and then use the reactive row following in between. We have a very clear API that, for example, triggers an implement to then lower the mechanical weeding tool, and then the robot starts its run.